Hi guys, Assalamualaikum. Annyeonghaseyo. So let's continue with chapter 3 today on part 2. Okay, so part 1 is on explaining the type and source of air pollutants and also air quality, such as air quality management, such as the use of API index, air pollution index. Remember? Okay, so now we are going to go to part 2 of the chapter 3, right? Okay, so now we are in chapter 3, part 2, where we are going to focus on the relationship between air pollution and atmospheric condition. Okay, so this will emphasize on the effect of meteorological elements on the dispersion of pollutants. So we will see. Okay, so in this chapter, right, so let me change to my pen first. Right. So in this chapter, we will see how these variables such as heat, okay, heat, pressure, wind, and also moisture will affect the atmospheric contaminants. Okay, so you will see all these four. You need to consider all these four variables on calculating the atmospheric contaminants means in air pollution, right? Okay. Okay, but first we need to go to understand what is scale of motion. Okay, scale of motion are related to mass movement of air, which may be global, continental, regional, or local. So you will see there are three categories. Okay, so this one, okay, 2, and also 3, right? So according to geographic range of influence, the scale of motion may be designated as macroscale, mesoscale, and microscale. So I believe that you can read by your own on this part, right? So I skip this. Okay, so these are the variables that I've already explained in the earlier part of this chapter. So, so now we are going to discuss how heat, pressure, wind. Another one is what moisture. Okay, will affect the atmospheric pollutant. Okay, the first one is heat. Okay, so for heat transfer occur in the troposphere, so you will see there's greenhouse effect, evaporation, conduction, convection. So I think you have learned this one earlier in your I think in any of chemical engineering subject. Okay, and then pressure. What is pressure? Pressure is the weight of the air above an object exert a force on the object. Okay, so the force exerted by an air mass is created by the molecule that makes it up and their size, motion, number, and present in the air. So, and then finally is the wind is a moving air. So you will see how later heat, pressure, wind will have the relationship with your managing your air pollutants. Okay, right. So air pollution dispersion. Okay, rate of dispersion of non-reactive pollutant determines concentration. So the solution to pollution is actually dilution. So our goal for this part is actually to predict air pollution concentration given the source and meteorology. Okay, so actually if you look here, okay, the solution to pollution is dilution. So, in the atmosphere, there are still pollutants, but the matter is how high the concentration it is, whether it is above the air pollution index. So that's what we wanted to know. Okay, that was how in was explained in part 1 of this chapter. So this part is on how you going to treat or going to control the air pollutant concentration. Okay, right. So this is the dispersion model that you're going to use in order whether to calculate the contaminant concentration or let's say given such concentration of contaminant, so how high is the stack that you need to build in order to to have an allowable concentration of your contaminant. Okay, so this is equation. Okay, right. Let me change to the pen. All right. So this equation is actually equation 8.3, okay, in your textbook. Okay, so equation 8.3, right? So where C is actually contaminant concentration, okay, and then X is downwind distance. So you will see in this figure here, okay, this figure is figure 8.9 in your textbook. Okay, figure 8.9, right? So you will see X actually the downwind distance. Okay, this is your X. See, so this along this is your X, and then Y is the crosswind distance. So you can see the crosswind distance. Q is contaminant emission, the rate, the flow rate, right, is in gram per second. So you need to focus on the unit, this meter, and then gram per second. And then what is sigma y is lateral dispersion coefficient function m. This you will you have to get it from the other graph that I will explain later, and also sigma z particle dispersion. So u is a wind velocity in downwind direction, and h is actually the effective stack height. So this is your stack. You see, can you see here? This is your stack. Okay, this part is your stack. Okay, so the height of the stack is the effective stack height, right? So if concentration along only the plume center line, okay, so you can simplify the equation being this equation lah. All right, and then if the effective stack height is 0, so this can be simplified to calculate the concentration of your X at your effective height is 0, meaning at the ground level. Okay, so all this equation you can refer in your textbook. Okay, this one is actually equation 8.4. This is actually equation 8.5. Okay, right. So these are the value of sigma z and sigma y, okay, in the earlier equation. Okay, so if you see here, all right, so you can see this is sigma y, so this is your sigma z. Okay, so this is the distance, this is the x that should be given in the question or in the statement, but you will need to choose one of this line. Like if you see here, what is A? Extremely unstable. B, so this is actually will be hint or would be informed in the statement on how is your weather, how is the weather used in that situation. So you need to, okay, if let's say later in example, okay, in example 8.3, all right, so I think example 8.3, no, sorry, so for example 8.1, okay, so in the example it stated that the atmospheric conditions are moderately to slightly stable, so maybe it's between B and C, so you're going to use it's either line B or line C. Okay, understand? Similar goes by this. Okay, so let's say your distance is actually 500 meter from the source, so maybe you can choose C. Okay, so what will happen here, right? Okay, if you look here, for example, if your x, say that your x is actually 500 meter, okay, so you choose here and then you extrapolate somewhere. Okay, let's say you choose the slightly unstable, or okay, moderately okay, sorry, unstable, so you choose this line C. So go to line C. So go to line C. Wait. C. Okay, this is C. And then you determine your sigma y from there. Okay. Right. Okay, so this is your sigma y. So you can express your sigma y from there. Okay. So this is your sigma y. So similar goes for sigma z. So this is your 500 going to C. Okay, sorry, I bit not accurate using my pen here. So you would determine your sigma z. Okay, that is one example. Okay. So this is the table that I'm referring to just now, whether to choose which one is your condition. Okay, so what we call this table is Pascal stability type. So you need to choose whether condition A, B. Okay, so based on the situation that given in the question, right? So you can refer to table. So this is actually sorry. So this is actually table 8.1. Okay, so table 8.1, page 503 in your textbook, right? So you need to choose this one first. You need to determine which class is actually okay. So this is day, this is night. So if it say sunny, you must choose day, right? Okay. So after you have chosen this, then only you go back to this graph to determine your sigma y and sigma z. Then only you can solve the equation 8.3. Okay. So what is class A? Very unstable atmospheric condition. B, so you can refer this in your textbook, right? So how to calculate the stack height? Okay, so given maximum ground level concentration, this is the equation. Sigma z is 0.707 times H. So H is actually your effective stack height. Okay, so this is actually the equation in your textbook page. What is the H? Okay. Alright, so this is actually in your textbook page 507. Okay. You may 506, you may refer to equation 8.7. So this is actually equation 8.7 in your textbook. Okay, so given to you the wind speed, stack velocity. Okay, so this is different from concentration. The earlier was to calculate the concentration of your pollutants. Now it is to calculate your stack height. Okay, right. Okay, now so let's quickly have a look on example 8.1. Okay, so in this example, okay, given a power plant burns 5.45 tons of coal per hour. Okay, so you need to convert this unit to a standard unit. Okay, and discharge the combustion product through a stack. Okay, a stack that has an effective height. So effective height 75. So this is your H. Okay, the coal has a sulfur content. Okay, this is sulfur content of 4.2%. And the wind velocity, this is your U. Okay, atmospheric condition are moderately to slightly stable. So I think might be B or C. Okay, so the condition is like B or C, right? Determine maximum ground level concentration of SO2. So they want SO2. So that's why, and also the distance from the stack at which it occurs. Right. So that's why. Okay. I think I will explain this example in the next video. Okay. Together with example 8.2 and also 8.3. Right. See you later. Bye.